Hey there, Mr. Chu here. Let's do one of my favorite lessons of the year in my geometry class, and that is a lesson of the introduction of trigonometric ratios. So, before we get started here, this is going to be lesson 10.02a in BRAC geometry. So please subscribe to Mr. Chu's YouTube channel at the link on the bottom right to see more geometry videos, and there are places that you can click on the link to subscribe. You can also go to my long link that I'll give you at the end of this video. All right, so now let's talk a little bit about right triangles. The lengths of the sides of the right triangles can be used to find the two acute angles of a right triangle by using the trigonometric ratios. The three basic trig ratios are sine, and we call that SIN. And Trey just come up to say hello to everybody. Trey is my 4-year-old black tomcat. There he is. And he likes to come and say hello every once in a while. And I name my arithmetic and pre-algebra videos after him. So anyway, you got sine, and we use SIN for the abbreviation of sine. Cosine, we use COS. And tangent, we use TAN as the abbreviations for those. The variable theta, which is the Greek letter that looks like a 0 with a line through the middle of it, is often used to denote an acute angle in a right triangle. The three basic ratios are defined below. So here they are, and they're kind of hard for some students to remember. The sine of theta is the side opposite of theta over the hypotenuse, and that's misspelled, hypotenuse. There you go. And the cosine of theta is the side adjacent to the hypotenuse. So each one of them will be misspelled here now, because I just copied and pasted. I apologize for that. The tangent of theta is the side opposite over the side adjacent. So you might be saying, oh, I'm never going to be able to remember that. I'm going to have to be asking Google to tell me what they are all the time. No, you're not. Mr. Chu's got you covered on that. That's why this is one of my favorites. So let's look at a right triangle. So there's a right triangle, and we got our right angle here. If we're talking about this angle here as being theta, that's not a 0, that's a theta. That's a 0 with a line through it. So you have to know that this side on the other side is called the side opposite. The side opposite of the right angle is called the hypotenuse. And then the side that is not the hypotenuse, that is the other leg of the angle you're dealing with, is called the side adjacent. So you just take those lengths and you end up getting a fraction or a ratio, and then you usually convert that to a decimal, and you'll see that in later trigonometry lessons that we do later in this unit. All right, so let's just go ahead and talk about how hard will it be to memorize the three basic trig ratios. So, and that should be asked as a question. So it would be hard, wouldn't it? Most people will just take and Google it and ask, but you don't have to, because Mr. Chu's got you covered on it. So remember, the side of theta is going to be the side opposite over the hypotenuse. The cosine of theta is going to be the side adjacent over the hypotenuse. And the tangent of theta will be the side opposite over the adjacent. And the hypotenuse is misspelled in these as well. But it only takes me a minute to fix it. And I apologize for that. So now let's look, what happens if it's a different angle? So in our first example, we talked about this being theta. What if this is theta down here? Well, then here's my side opposite. Here's my side adjacent. Here's my hypotenuse. Now remember, the side opposite, you just go through the triangle. The hypotenuse is opposite the right angle. And then the side adjacent is the side that's not the hypotenuse, that is a leg of the angle you're dealing with. Okay, now those are important. If you can't do them, you can't do the trig. So, how hard will it be to memorize these? I already asked that before. Since I was a math and an English major during my bachelor's study at college, I've always enjoyed to write and create and be a storyteller. So here's Mr. Chu's story that'll make remembering all three trig ratios easy. Now it's story time. I call this my Indian princess story. My story takes place many, many moons ago. There was a beautiful Indian princess who was the only child of the chief. And the chief was happy when she found her a warrior husband who was the strongest and most brave warrior. The chief was even more happy when they had a son. Now, the hierarchy in this particular tribe would say that the princess could not be in charge, but her son could be chief someday. So here's the son. Now, just like the warrior husband who was the strongest and most brave warrior of all, their son happened to be the fastest runner out of all of the Indian children. So one day, when the warrior husband and all the other young men who were fit and able to go out on the big hunt before winter were out hunting, all the children were home with the females, which included the princess, and the elderly, which included the chief, who weren't able to go on the hunt. So these children were out playing, and there were a bunch of Indian children, and they were running through the woods, and they spooked up a deer. And of course, these young male boys thought they were as fast as that deer, and they started chasing it and running after it. Well, who do you think was the fastest of all of them? It was the son of the princess and her warrior husband, soon to be chief at another time later on in the future. So he's out chasing after this deer, and he's running as fast as he can, and he's getting farther and farther ahead of the crowd of all the other children. And that deer is pulling away from him, and it jumps over a stream. The little boy tries to scale the stream and jump over it, and he hits his toe on a huge stone on the far bank of the stream. Well, if you think about Indians and how they used to dress, they were wearing moccasins, and they had a very thin sole on them. So he stubbed his toe really, really bad. Have you ever really stubbed your toe bad where it bled and it hurt and you usually say something you shouldn't? Well, that was the kind of stub this was. Well, even though he's supposed to be chief someday, he's still a little boy who cried as his toe bled. So he came on back to his princess warrior, to the princess, the warrior husband's wife, the daughter of the chief, and he's crying. And the chief comes into their teepee and says, "Boy, not cry." And the princess said, Oh, come on, Daddy-O. How are you going to get him to stop crying? She's trying to be a modern princess. How could he soothe that stubbed toe? And the chief says, So, Katoa. Soak a toa. Soak the toe. So, we can use this. The so means the sine of A. S is the sine. Equals opposite. O is opposite over hypotenuse. The cosine of A, adjacent over hypotenuse. The TOA, tangent of A, opposite over adjacent. So you may say, oh, come on, Mr. Chu, I'll never remember that because those letters are kind of weird. But my story's not over about the Indian princess and the chief and this particular tribe. Something else happens. While the princess is soaking the little boy's toe, there's commotion outside with all the horses back behind the chief's teepee in the corral. And what happened? Well, they know that the horses are starting to stampede for something. The horses were upset because one horse was caught taking another horse's oats, so they stampeded. Now let's reword it for Trig. Some other horse caught another horse taking oats away. See that? There's my SOH, so CAHKTOA, taking oats away. And remember, the sine of an angle is the opposite over the hypotenuse. That's so. Cosine of an angle is the adjacent over the hypotenuse. And then the tangent equals the opposite over the adjacent. Now let's just look at an example and see if we can use this and figure this out. All right, here's example 1. Find the ratios SOHCAHTOA. Find the trig ratios for the cosine of A, sine of A, tangent of A, cosine of B, sine of B, tangent of B in the right triangle below. So if I look at A first, which is in red, let me go ahead and mark on this. So if we're dealing with this angle right here now, remember for this angle, we've got the opposite, we've got the hypotenuse, and we've got the adjacent. Okay? So if that's what we've got now, remember what the sine of A is. It's the opposite over the hypotenuse. You remember what the letters were? So the side opposite is 8 over 17. Now, it's that simple. Now, when we're working later on, you'll be changing that to a decimal. The cosine is ca. And remember the ca is adjacent over hypotenuse. So 15 over 17. And then the tangent, remember what tangent is? Toa for soka toa. So that is opposite 8 over adjacent 17. 8 or 15, sorry. 8/15. All right, so now we'll change to blue. Whenever I'm writing. And remember, the sine is so. the cosine is cut. And the tangent is TOA. Now, since we're dealing with now we're dealing with B. So now we're dealing with B. So I'm going to put this in blue and I'll put 2 arcs here. And remember, for the blue now, this is the opposite. This is the adjacent. And remember, adjacent is the side that makes up the angle that's not a hypotenuse. All right. So now let's just find the sine of B, which remember what sine is. Opposite, 15 or 17. And yes, there is a correlation, and we'll talk about that in later lessons. The cosine, adjacent, which is 8, over hypotenuse, which is 17. And then tangent, which is TOA, well, opposite over adjacent, opposite 15 over 8. So there are correlations here, and we'll talk about them in later lessons. All right, now here's a do you understand? So in a do you understand problem, what we want you to do is, we want you to pause this video, get out a piece of paper and pencil, try to solve this on your own before we discuss it step by step. So pause this, get out a piece of paper, and it wants you to find the cosine of A and the sine of A. So remember, we're dealing with this angle is our theta, so we're dealing with A. And you need to use SOHCAHTOA. Pause this and find it now. Remember that once you finish your problem, start the video back up, and then we'll answer it. So let's work this problem now. So, which trig ratio represents the cosine of A and the sine of A in this right triangle? All right. So remember, the sine of A is so. So let's take and let's look at A. And we know that this is going to be opposite. And this is going to be the hypotenuse. So that would be 8 over 10. And the cosine of A would be chi, which is adjacent over hypotenuse. And this is the adjacent right here. So that's going to be 6 over 10. So that's choice 4. Hopefully you're able to get that right. And usually this would be called 4/5. This would be 3/5. And then you would write that as 0.8000 and 0.6000, but we'll deal with that later. All right, so now I want you to take, and I want you to see if you can find out, if you can do this one on your own now. Solve this problem now. Which trig ratio represent the cosine of A, sine A, tangent of B in the right triangle below? The answer to not simplify, choose the correct answer. So work on those now, and then you will see where the answers are. You can pause this if you want. We're not going to give you the correct answer now because we want you to be able to come up with that on your own. This problem is explained as example, it would be 4 in the Crack Geometry Lesson 10.02b, trig ratios. There'll be a link on the last screen here, and at the top left of the screen, it's where it'll show up. It'll also be in the comments and in the description. So make sure you follow me. I got lots of math videos and fun puppy videos. A link to a video will be up here to explain that example 4. There also will be 3 challenge problems after several other examples in that 10.02b where we start learning more about trig. So here is the long link to my YouTube channel, and you're watching this on YouTube right now. There should be a link over here or underneath on your device. If you need to ask me any type of a math question, I will answer it, make a video for you. My email address is askmrchew@gmail.com. Help spread the word that Mr. Chew will help students with math questions using videos in my curriculum. And I call my algebra curriculum Bare Algebra, and there's videos for that. Crack Geometry is what we do this trig in. I have Trig Arithmetic, and if you were watching earlier, you saw Trey jump up on my lap. Trig Arithmetic and Pre-Algebra. I also have several videos called Math Minutes, which are a little bit shorter math problems, and I've been doing a lot of SAT test preps. I'll see you in the next video. We'll do more trig if you click on that link. And remember, I'm Mr. Chew, and I want to help you learn geometry. See you next time.